Hi everyone, this is Professor G, and in this video we're going to do a little bit of algebra, specifically solving equations. You see part one on the screen, so I'm going to split this video up into two parts. In this video, I'm going to start off with a little bit of lecturing first, a little bit of explanation, and then we're going to talk about how to solve a few different types of equations. We're going to talk about linear, rational equations, formulas with multiple variables, and absolute value equations. And then the second video will pick up exactly where this one left off with just a few more examples. The part two is going to focus on quadratic equations. In this video, I'm going to work through about 5 problems. But before we do so, the focus here is solving equations, right? Oop, didn't want to go forward yet. The focus here is solving equations. So sometimes that word solve is used but not actually explained fully. What does it mean to solve an equation? And first of all, before we talk about solving equations, what is an equation? So before we start looking at the examples, let's start with a definition. An algebraic equation, it's a declarative statement. It's a statement or a sentence that's declaring something, in this case written in the language of algebra. And it says that two algebraic expressions have the same value. Two expressions have the same value. In the same way that a $1 bill. So this is a $1 bill. There's probably someone on this picture, someone here. So $1 bill has the same value as 4 quarters. They look different, right? 25 cents. Each of these is 25 cents. They look different. They feel different, but they mean the same thing. $1, 4 quarters, 2 ways of expressing the same value. And so this is like how an algebraic equation works. The two sides of the equation, the left of the equal sign, the right of the equal sign, have to have the same value. So to solve, right, to solve an algebraic equation, for example, down here, 2x plus 1 equals 7. Right? To solve an equation like this, well, the equal sign is declaring that the 2x plus 1 on the left and the 7 on the right have the same value. We're going to get into some more complicated problems in this one, but we'll start with a simple one. To solve the equation, we're looking for numbers, maybe one number or possibly more than one number, that when replaced for the variable gives you a true statement. We call this evaluating a variable, plugging in a number for a variable. Remember, a variable is a symbol. In this case, the x is a symbol used as a temporary placeholder, right? Just a temporary placeholder. So this x is here for the moment until we figure out what it is. So to solve the equation means to find a number that gives you a true statement. X can't be just anything. If we replace x with the number 5, right? So instead of 2 times x plus 1 equals 7, it's 2 times 5 plus 1 equals 7. Well, that's not true. That is a false statement. 2 times 5 is 10, plus 1 is 11. We get 11 equals 7. That's definitely not true. And since that's not true, 5 is not the answer. Right? 5 is not the answer because it did not give us a true statement. All right, so let me erase this. On the other hand, if we replace x with the number, let's say 3, so 2 times 3 plus 1 equals 7. That is a true statement. And this is what it means to solve. Find that number, or possibly numbers in different types of equations, that when you plug it in for the x, so you replace the x with it, you get a true statement. 2 times 3 plus 1 is actually 7. So that's a true statement. So 3 is the answer. That's what it means to solve. X equals 3. It's figuring out that number that we need to plug in. for the variable. Now, with this equation, it was small numbers, whole numbers, positive numbers. It was easy enough to do without writing anything down. 2 times something plus 1 equals 7. Okay, well, we can do that in our heads most likely. Now, what happens when the problem is more complicated, where we can't just look at it and figure it out without writing something down? So I'm going to jump ahead to the next slide and then come back to this one. So for example, 2 slides later, number 1, here's a similar equation. Solve the equation. Well, this one, x divided by 5 equals 4 plus x minus 6 divided by 3. We'll get to this in a moment, but this is something we're going to have to write this down, write out some steps. It's going to take multiple steps to solve this problem. So we'll come back to that. The way we approach any problem in algebra, and this is probably the single most important statement in the entire course, in the entire class of algebra. If you're taking an algebra class, this is probably the single most important statement that you'll see or hear in the entire semester, because this is how we solve equations, and solving equations is something we do more than anything else. There's a lot of other things we do in algebra, but solving equations is going to be something we do more than anything else. You could change the value of one side of an equation in any way you like, as long as you change the value of the other side in exactly the same way. Now, when I'm going to be referring to sides, left side, right side, I'm talking about the left of the equal sign. That's the left side of the equation. And then to the right of the equal sign is the right side. Okay, so when I'm saying left side, right side, I mean left of the equal sign, right of the equal sign. And before I move on to the next slide, let me just reiterate, like in the definition of an algebraic equation, it's a declarative statement written in the language of algebra, right? Algebra is a language like any other language, like French or Arabic or German or English or math. They're all languages, right? So if you happen to speak 2 languages, then you're familiar with the concept of translating from one language to another. Right? If you speak both English and French, then you could take a statement in English and translate it to French, or if you could take a statement in French and translate it to English. Right? That's what we have here. See this little double arrow I have here on the bottom? It's the same thing written in 2 different languages. Right? On the left-hand side, this is the language of math, and on the right-hand side, this is the language of English. It's the same thing. When you double a number, that's the 2 times x, the a number, right? That's the unknown. So some number x. When you double it and then add 1, the result is 7. What is the number? All right, so we're able to write it a little bit more compact, more succinctly when we use the language of mathematics. All right, but we're, especially later on in, in most of the videos that are going to come after this are going to be including word problems, because this is we're about done with chapter P, with the preparatory or prerequisite material. When we start getting into precalculus, we're going to be doing a lot of modeling, a lot of word problems. So this translating between math and English, English and math is going to be an important step in many of the problems that we're going to be doing. Okay, so now let's focus on the second statement. To solve an algebraic equation means to find a number or numbers that, when replaced for the variable, give you a true statement. So the way we do this, the way we solve an equation is by that third statement, by changing the values of each side of the equation. I have a visualization of this. Let me stick with this problem. 2x plus 1 equals 7. I'm going to write this on the next slide. 2x plus 1 is equal to 7. Now, Let's say you're not, let's just hypothetically, you're not able to figure out that x has to equal 3. How, like, what step-by-step process would we take to solve for x? Well, an algebraic equation is a statement that two expressions have the same value. So you see at the bottom here, I have these two pictures, these balance beams. It's like an old-fashioned scale. The equal sign is telling you that both sides weigh the same or have the same value. So the 2x plus 1 would be on the left side of the scale. So there's the 2x plus 1. Let me make it a little bit darker. Okay, 2x plus 1 is over there, and the 7 is over there. That's what an equation looks like visually. Right? It's a scale where both sides weigh the same, or a balance beam where both sides weigh the same, have the same value, not literally weigh, but have the same value. So when we're solving an equation, we want our final answer. So we want to follow a sequence of steps, and then we want our final answer to be a more simple statement, more direct. X is equal to a number, right? Once we're here, that's our answer, right? That's what we want. So how do we get from start to finish? Well, we have to eliminate everything around the x. We want to isolate the variable, get x by itself. Right, so that's sort of the with using informal language. That is the goal. Let's say over here, goal. To get x by itself, let's say on one side. To get x by itself on one side. That's our goal. Now, the way we do that is by removing anything that's around the x. Removing anything that's around the x. Now, there's two things happening to the x right now. It's being multiplied by 2. And then there's a plus 1. So there's a times 2 and a plus 1. Now, each operation in mathematics, at least each operation in this problem, has what's called an inverse, an opposite. So the opposite of plus is minus. The opposite of times is divide. Right? That's the inverse of the inverse operation of plus is minus. We don't have to worry about the word inverse, but think inverse, loosely think the opposite or the reversal. So how do we eliminate a plus 1? Well, we could eliminate a plus 1 with a minus 1. So if we subtract 1 from 2x plus 1, what does that give us? It gives us 2x. All right, so now we got 2x equals 7. Uh-oh, now there's a problem. So what just happened was I decreased the left-hand side. I lowered the left-hand side by 1, so now the 2x is over here. Now I'm over here. The 2x is worth less because I decreased it. I subtracted 1, and the 7 is now heavier, metaphorically heavier, right? I didn't do the same thing to both sides, so now the equation is not balanced. It's no longer equal, right? Now it's not equal. Right, so we want to avoid that. We want to avoid that. So let me go back to our equation. Whatever we do to one side, we have to do to the other. So we're allowed to subtract 1 from the left as long as we subtract 1 from the right. And now we have 2x on the left-hand side, 6 on the right-hand side. So remember, x equals a number. That's what we want, x by itself. Not 2x plus 1, not 2x, but we want x by itself. Right now, x is being multiplied by 2. To eliminate times 2, we divide by 2. I'm using a fraction because fraction means division. So I'm going to divide both sides by 2. I'm showing my work in red, and I'm simplifying the equation in blue. So step 1 was I minus 1 from both sides. Step 2, divide both sides by 2. The important thing is both sides. 2 divided by 2 is equal to 1. Any number divided by itself equals 1. So x is equal to 6 divided by 2, which is 3. Okay, we're going to be, for the rest of this this video, we're going to be working on more complicated equations. But we talk about how to solve them using a simpler example, and then the methods that we use, we could then apply to more complicated problems. Okay, so let's get into a problem. Number one is a linear equation. The definition, a linear equation so there's many different ways we could state the definition. So one thing I could say is a linear equation, x is only raised to the power of 1. That's it. No x squares, no x cubed, no powers of x, no square roots of x. It's just x by itself, or something times x is fine, but no exponents other than 1 on the variable. A more textbook definition, we could say a linear equation is any equation of or equivalent to the form, so of the form or equivalent to the form a times x equals b, where a and b are any number, any real number, and a can't be 0. Right? If a is 0, 0 times x is 0, everything's 0. So for a linear equation, there's got to be an x in there, so it can't be 0x, because then there's no x's. So definition of linear equation is any equation that looks exactly like that or is equivalent to that. It can be made to look like that. That's what we mean by linear equation. It's got an equal sign and it's got an x, and that x is raised to the first power. In the next video, we're going to talk about quadratic equations, x to the second power. But in this first case, linear equation. Now, over here on the left, the problem we want to do, x over 5 equals 4 plus x minus 6, all divided by 3. Well, we got some work to do here. Let me go back a slide. And I really want to focus on this goal, where I say goal, to get x by itself on one side. This is what we want. Oops, I didn't mean to do that in yellow pen. I wanted yellow highlighter. Okay, this is what we want. X is equal to a number. All right, so we have the original problem, and then we know what the answer should look like. We just have to connect the dots. We have to connect start to finish. So there's going to be some steps, and eventually we're going to get x equals a number. Okay, that means x on one side, number on the other side. So we're going to need to move all the x's to one side of the equation. It doesn't matter if it's the left or the right, but you got to get all the x's to one side, numbers to the other. And we have freedom here. We could do it. There's a lot we could do because of that equal sign. Because of that equal sign. A common approach is if the original problem contains fractions, let's get rid of the fractions. Let's eliminate fractions. So what we could do is we've got this fraction x over 5 equals, and we could even treat 4 like it's a fraction. 4 over 1 plus x minus 6 all over 3. All right, so we have denominator 5, denominator 1, denominator 3, and our lowest common denominator is equal to 15. Right, the lowest common denominator is the smallest number that is divisible by every denominator. 5 goes into 15 3 times, 1 goes into 15 15 times, and 3 goes into 15 5 times. All right, so step 1 is find the least common denominator. And then once we have that, this is the reason we're finding the least common denominator is not to combine fractions and get a common denominator. What we want to do with the least common denominator is use it. So let me write this. Use this to eliminate fractions. Use this to eliminate the fractions. The way we do that is we take the equation. I'm going to rewrite the equation. I'm going to be doing a little bit more writing than maybe you would do if this was a problem you were doing on your own. X minus 6 over 3. We would take the least common denominator and multiply both sides of the equation by that number. I'm going to write 15 over 1 because we're dealing with multiplying fractions. So sometimes it helps visually to make the whole numbers also into fractions. So times 15 or times 15 over 1, same thing. Also on the right-hand side, I'm going to multiply by 15. If you multiply both sides of an equation with fractions, if you multiply both sides by the least common denominator, it's going to eliminate all of the fractions. So on the left-hand side, if we multiply fractions, top over top, bottom, or top times top, bottom times bottom, that'll be 15x over 5 equal 15 times 4 is 60. So we're distributing the 15 to everything on the right-hand side. Everything on the right. So that's 60 over 1, 4 times 15 on top, 1 times 1 on the bottom, plus, I'm not going to distribute the 15 to both the x and the negative 6, but let's just say 15 times x minus 6, all divided by 3. Now, if we take a look at this, that's a whole number. 15 over 5, that's a whole number. That's not, we don't need to write that as a fraction. That's 3. 60 over 1, that's a whole number. 15 over 3, that's a whole number. So now everything is a whole number. So 15, there we go. 15 over 5 is 3, so that's 3x equals 60 over 1 is 60 plus 15 over 3, that's a 5, and then we've got an x minus 6. I gotta erase this. I need a little bit more board here. All right, so now we no longer have any fractions, right? And this always works. I'm going to take the exact same approach in the next problem, which is a different type of problem, but it contains fractions. So a good rule of thumb is if your equation contains fractions, get rid of them as your first step. figure out the least common denominator, multiply both sides by that. It'll cancel off all the denominators. All right, so now let's bring it up here. We got 3x equals 60 plus we could multiply both the 5, distribute the 5. We want to start removing symbols, simplifying. So let's get rid of those parentheses. So 5 times x will be 5x, and 5 times -6 will be -30. Remember, like everything we do, every step should get us closer and closer to what our answer is supposed to look like. X by itself on one side, a number on the other side. So we've got a 60 and a -30. Those are like terms. We could combine those. We still got a 3x. We still got an equal sign. We still got a plus 5x. But the 60 and the -30, that gives you positive 30 plus 5x. We're getting close. We're getting close. We don't want x's on both sides. So there's already a number. There's already a 30 on the right. So let's get rid of the x. The opposite of plus 5x is minus 5x. So we could subtract 5x from the right-hand side. That will give us 30. Whatever we do to the left, we have to do to the right, and whatever we do to the right, we have to do to the left. So if we did a minus 5x on the right, we got to do a minus 5x also on the left. So 3 minus 5 is a -2, so we'll have -2x. Well, what do you know? It now looks exactly like the definition of a linear equation. It just started off more complicated, but we simplified, 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 and now it looks like a number times x equals a number. All right, so a linear equation, it either looks like something x times something or equals something, ax equals b, or it starts off more complicated, but it could be reduced or simplified into that form. Now, last step, we want to get x by itself. So we have to, right now, x is being multiplied by -2. The opposite of times -2 is divide by -2. So we will divide both sides by -2. -2 divided by -2 is 1. So on the left, we get 1x or just x. And on the right, 30 divided by -2, -15. And so that's our answer. So in the original problem that's up on the top left, if you replace those two x's, each of those two x's, if you replace them with the number -15, you will get a true statement, the same number on both sides. Okay, not every linear equation is going to look just like this one, but we take the same general approach. Get all your x's to one side, numbers to the other side. You want to simplify until you get to a point that you're down here. X equals a number. Right? Then there's our solution. Okay, next problem. Well, this is not a linear equation. This is what's called a rational equation. A rational equation contains at least one rational expression. Talked about rational expressions in a previous video. If the word rational expression isn't ringing any bells, you might want to pause this and go back to one of my previous videos on rational expressions. I think it might have been section P.4, P.3, P.4, somewhere there. So we're going to take this and basically solve it the same way. We'll solve it the same way. But first, we want to determine the value or values of the variable that make the denominator 0. Right, these are called restrictions on the variable. X is not allowed to be any number that gives you a 0 on the bottom. So if we look at this, x plus 1 is the denominator. Well, -1 plus 1 is equal to 0. So x cannot equal -1. If x is equal to -1, then you get in that middle fraction will be 6 divided by 0. You're not allowed to divide by 0, which means x is not allowed to be -1. And that actually works here as well. If x is -1, then 3 times x plus 3 is also 0. And so we need a -1. So x is no matter what, x cannot be -1. If we solve the equation and we get a final answer that says x equals -1, we would say, actually, nope, that doesn't work. There are no solutions. So it's possible to get no solution. Okay, so let me write this over. Let me write this over here. 8 divided by, well, in a previous video, earlier on in this chapter, when we talked about rational expressions, we said one of the first thing you want to do is simplify the rational expressions. We talked about adding and subtracting, multiplying, dividing. So you want to factor the denominator. So instead of 3 times x plus 3, I'm going to write 3 times parentheses x plus 1. I'm going to pull out a common factor. Talked about factoring in, again, a previous video. There was one video, the entire video was on factoring. Equals 6 divided by x plus 1. And for anyone watching this, you could find the links to all the previous videos of this section. There's a link to my website in the description of this video. Okay, so we got -2/3. We have 3 fractions, just like in the last problem. Let me scroll back up for just a moment. I'm looking right here. Right now, first denominator was 5, second one was 1, third one was 3. So we looked for the least common multiple of those 3 numbers, which is the least common denominator. So we're going to do the same thing in this problem. We need to find the least common denominator, which in this case is going to be 3 times x plus 1. Because 3 times x plus 1, it contains the first denominator. It's actually the exact same as the first denominator. Right? It contains the second denominator. There's an x plus 1 in there. And it contains the third denominator. There's a 3 in there. Right? So we find the least common multiple of the denominators, or the least common denominator. And we're going to multiply both sides of the equation. So I'm going to write it out a little bit funny to begin with. 3x plus 1 equals 6 over x plus 1 minus 2 over 3. Now, we're going to multiply both sides of the equation. right? You have a lot more freedom with an equation when there's an equal sign, because you can make changes to both sides. You can do whatever you want. In this case, I'm multiplying both sides of the equation by the 3 times x plus 1. Right, the reason I'm doing this, let me switch to, I don't know. Let's do orange. The reason I'm doing this is because this will, again, just like in number 1, cancel off each of the denominators. So in the first term on the left, the 3 on the top, 3 on the bottom cancel. The x plus 1 on the top, x plus 1 on the bottom cancel. Second term, just that x plus 1 on top is going to cancel the x plus 1 on the bottom. And then the third fraction, the third term, the 3 on the top is going to cancel the 3 on the bottom. So the denominators completely cancel. So we're left with 8, right? That first fraction, everything cancels except the 8. 8 equals, we have a 6 times 3, which is 18, minus, we still got a 2, and we still got a parentheses x plus 1. All right, much more straightforward problem now that we've eliminated the fractions. All right, so we have 8 equals 18. We could distribute that minus 2 times x, and minus 2 times a 1. So we'll have 8 equals 16 minus 2x. 16 minus 2x. Right? On the right-hand side, we've got an 18 and a minus 2. 18 minus 2 is 16. We want to keep our x on one side, numbers on the other, so we could subtract 16 from both sides. Minus 16 minus 16. Eight minus 16 is negative 8. Then the 16 and the minus 16 on the right cancel. We have a negative 2x. Divide both sides by negative 2. I'm going a little quicker because this is something we've done already many times. Divide by negative 2. Divide by negative 2. So on the right-hand side, we've got an x by itself. We've isolated our x, and on the right, negative 8 divided by negative 2 equals positive 4. So 4 equals x equals 4, same thing. So you could add to both sides, you could subtract from both sides, you could multiply both sides, you could divide both sides, as long as you're using the same number on both sides. Doesn't matter if it's a number or a variable. In number 1, we multiplied both sides by 15. Number 2, we multiplied both sides by 3 times x plus 1. Right? It doesn't matter if it's a number or variable, it just matters that you're doing the same thing to both sides. Okay, number 3, slightly different type of problem. There are no numbers. You just got a formula. Solve the formula for f. So what does that mean? Well, we've talked about what it means to solve. Isolate the variable. In this case, the variable is f. The variable we're looking for is f. So solve the formula for f is the same as saying isolate the f. And that also means the same thing as you want f equal sign and then everything else, right? F on one side, everything else on the other side. So this all means the same thing. We want to get f by itself. Right now, it's in the denominator of a fraction. We want to get rid of that. So problem 1, problem 2, and now problem 3 look different. They look very different, but the first step is the same. We want to get rid of the fractions. We want to get rid of the fractions. So let me write this over. G equals B divided by F minus V. So let's multiply both sides of the equation by F minus V. The reason we're doing that because this will cancel off the denominator. So the F minus V on the right-hand side of the equation, the F minus V on the bottom cancels off with the F minus V on top. So we're left with F minus V times G is equal to, and on the right-hand side, we've got B. Okay, we're one step closer. We still got some work to do. We've gotten rid of the fraction. F is no longer in the bottom of a fraction. We want to get F by itself. So we got to break up those parentheses. We got to get F out of those parentheses. So let's distribute the G. This is all things we've done before. The only difference is here, it's letter times letter instead of number times letter, but the mathematical operations are the same. So F times G minus V times G is equal to B. Again, we want F, we want this. Let me use a green here because this is what our answer should look like. F on one side, everything else on the other. We're getting closer. We got to get rid of that minus VG because there's no F there. That's easy to do. It's something we've done before. The opposite of a minus is a plus. We're going to add. Oh, let me use red. I usually use red for this part of the writing. Plus VG. All right, you just do the opposite. The fact that it's all letters doesn't change the approach. They cancel. And we're left with F times G. And we're almost there. We almost have F by itself. If we add a VG to the left, we got to add a VG to the right. So that's B plus V times G. And then finally, right now, the F is being multiplied by G. Opposite of that is divide by G. Those G's will cancel. Those G's will cancel. And we've got F is equal to B plus V times G all over G. It doesn't look nice, but it doesn't matter. The right-hand side doesn't matter. We are done. We stop as soon as we've got F by itself. So the same approach we took for problem 1 and 2 is how we started number 3. Different type of problem, but we saw a fraction, we want to eliminate it. Okay, 2 more to go, and we're almost done. The last 2, we should be able to wrap up in just a few minutes. Next type of equation that you may see is an absolute value equation. Now, an absolute value equation is any equation that involves the absolute value of a variable. So we've got an X inside. These are the absolute value bars, these vertical bars. That's our symbol for absolute value. The definition of absolute value is distance from 0. Distance is always positive. So if this is 0, and over here is the number 3. Oh, no, not negative. Ooh. Number 3. And over here is the number -3. Well, the absolute value of -3 is equal to the absolute value of +3 because they're both the same distance from 0. 1, 2, 3 spaces to the left. 1, 2, 3 spaces to the right. They're 3 and -3 are both 3 jumps, 3 units away from 0. So they're both equal to 3. So for any number x, the absolute value of x is equal to c, where c is any number. So let's treat this like an if-then statement. Here is how we do absolute value equations. If you have the absolute value of something, it may not be x by itself, but the absolute value of something equal a number. In this case, we've got the absolute value of 2x minus 3 equals 7. And this is what we're working with. Then x is equal to c. And we're going to get maybe 2 answers here. Say x is equal to c and x is also equal to -c, because the number line goes in 2 directions from 0. So what this is saying is 2x minus 3 equals any number that is 7 units away from 0. Right? 2x plus 7, or sorry, 2x minus 3 equals 7. So 2x minus 3 is any number that is 7 units from 0. There's 2 of them. 1, 2, 3, 4, 5, 6, 7 units that way. There's one answer, 7. 1, 2, 3, 4, 5, 6, 7. There's -7. That's another one. So 2x minus 3 equals both of those numbers. C is a number, but C, let's say parentheses, or let's say quotations. We'll say the number C can't be negative. Can't be negative. C can't be negative because distance has to be positive. So let me switch to blue and we'll solve this one real quick. 2x minus 3 absolute value equals 7. Well, using this definition over here I have in the box, we could rewrite this as 2 separate problems. That's 2x minus 3 equals +7. So this is us using up those absolute value bars. We're using up the absolute value bars by saying the 2x minus 3 equals 7, and 2x minus 3 also equals -7. It equals both. We're going to get 2 answers. We're going to solve them the same way. So on the left, I'll start by adding 3 to both sides to get rid of that 3. So 2x equals 10. On the right, I'll do the same thing. I'll add 3 to both sides. So I'll get 2x again equals, but in this case, -7 plus 3 will be a -4. Then to get x by itself, I'll divide by 2. I'll divide by 2 both sides. Same thing on the right. I'll divide by 2, divide by 2. So one answer will be x equals 10 divided by 2, which is 5. And the other answer will be x equals -4 divided by 2, which is -2. Right? So One equation, two answers. The final answer could be negative. The final answer could be negative, but the original absolute value can't be equal to a negative number. Okay. So last problem, and this one will be the quickest one. Easy to make a mistake on this one. Very easy to make a mistake on this one because this is another absolute value. But in this case, we've got absolute value of x plus 4 plus 9 is equal to 2. So we want to get x by itself. And let me go back to the previous slide. Over here, this is our rule for solving equations that look like this. Right? It has to look exactly like this. The absolute value of something on the left, a number on the right. Right? Absolute value of something equals a number. Problem 5 doesn't look exactly like that. There's a plus 9. So we don't have just an absolute value on the left. Let's get rid of that plus 9. That's easy enough to do. We'll subtract 9 from both sides. Take away 9 from the left, take away 9 from the right. Now, we've got absolute value on one side, number on the other side. Problem is, that number is a negative. So we've got the absolute value of something equals -7. That's impossible. You cannot have an absolute value equal to a negative number. If you ever see this, you're done. You stop. That problem is not solvable. There is no solution. So the answer to the problem, the answer here would be this equation has no solution. All right. That is it for part 1 of this video. I'm just going to continue on in the next video and do 3 or 4 more problems, but the rest of the problems I'm going to do, number 6, 7, 8, and 9, I think, will be quadratic equations. So next video, quadratic equations. That's it for this one. I hope this was helpful, and I'll see you on the next one.